Hello students, in continuation with our discussion on assertion and reasoning series, we'll today take up questions on magnetic effect of current and magnetism. In our previous discussions we have done, in first one we have discussed how we should attempt assertion and reasoning type questions there. In second one we have discussed assertion and reasoning questions on electrostatics, and in the next one we have discussed questions on current electricity. So today we are going to discuss questions on magnetic effect of current and magnetism. Let's continue with our discussion on assertion and reasoning questions on magnetic effect of current and magnetism. Let's take next question. Again, here we'll see what are the options there. First option is assertion and reason both are correct statement and reason is correct explanation for assertion. Second one is assertion and reason both are correct statement but reason is not the correct explanation for assertion. Third one is assertion is a correct statement but reason is wrong statement. And the fourth one is assertion and reason both are wrong statements. So now let's see the statement of assertion. Magnetic poles of Earth do not coincide with the geographic poles. Now this is true, because if you consider Earth, that this is, suppose Earth, this is the axis. Suppose I take the geographic north and south here. It is believed that the magnetism of Earth is due to, say, a hypothetical magnet. Of course, it is not the correct reason, but just for the basic understanding, we can assume that its orientation is not exactly in this direction. It has its south pole in this direction, where it is the north, and this is the south. So its orientation is there at some angle. So this is the, suppose I assume that this is the position of the geographic pole. The magnetic pole is somewhere here. So it is not at the same position. So in that case, they are not coinciding. That means this is true. And reason is given, the discrepancy between the orientation of the compass and the true north-south direction is known as the magnetic declination. This is also true, because the declination which we take, that is the angle between the geographic and magnetic meridian at a particular place. So if you take a freely suspended magnet, it will get aligned in the direction of the magnetic field. So it is basically in the direction of the magnetic field of Earth, not the geographic north and south direction. So obviously that particular angle, we take it as the declination. So now both are true. Now let's just see whether first option is correct or the second one. So the magnetic poles of Earth do not coincide with the geographic poles because the discrepancy between the orientation of the compass and the true north-south direction is known as magnetic declination. Now this is true, but here if you consider, it will also indicating that why it does not get aligned in that particular direction. So that means the first option is the correct one. Let's take the second one. Again, it is the same options there. Assertion is the angle of dip is maximum at the pole of the Earth. So at the pole, if you consider the angle of dip value is what? We can take tan theta as BV by BH. And if you consider at the pole, this horizontal component becomes 0. And if it becomes 0, in that case, what will be the value of tan delta? This is your BV by 0. That means it is infinity. That means delta is your pi by 2. So this is maximum at the pole. That means this is true. Second, that is the reason which is given. Magnetic field lines are parallel to the surface of Earth at the pole. Now, this is not correct. Magnetic lines of forces will be there passing through the poles of the Earth. In that case, if you consider, they will be perpendicular to the surface of the earth at that particular point. So this is false. So here assertion is true, but reason is false. That means it is the third one, which is the correct option. The next question. When radius of a circular loop carrying current is doubled, the magnetic moment becomes 4 times. Because magnetic moment, if you take, it is your I into A. That means we can take it as your I into pi r square. So if it is said that radius is doubled, so that means you are making this r double, so it is r square term, so it will become 4 times. That means this is true. And now the reason, if I take, magnetic moment depends on area of the loop. Now this is also true. Clear? So magnetic moment is depending upon the loop. But now if I just read it together, the radius of the circular loop carrying current is doubled, its magnetic moment becomes 4 times, because magnetic moment depends upon area of the loop. Now here it is not explaining it that why it will become 4 times. Radius you are making double, it is becoming 4 times, and magnetic moment depends upon area, but why it will become 4 times, that was not explained there. So in that case, assertion and reason both true, and reason is not the correct explanation. So obviously this is the second one, which is the correct option. Let's take next one. Magnetic field of an atom is due to both the orbital motion and the spin motion of electron. Now this is a correct statement. Why? Because if you have a charged particle, it will, and it is in motion, it will produce magnetic field. So here you have the electron moving in the atom, so it has orbital motion as well as a spin motion, and for both it will be contributing for the magnetic field. So magnetic field of an atom is due to both orbital and spin. This is a correct statement, so it is true. Next is there, a charged particle produces magnetic field. Now here it is said charged particle produces magnetic field. Charged particle, if it is in motion, then only it will produce magnetic field. In fact, a static charged particle will produce electric field. If the charged particle is in motion, it will produce electric as well as magnetic field. So here, if it is just said that it is producing a magnetic field, a charged particle produces a magnetic field, it is not a correct or complete statement. So this is false. So assertion is true, but reason is false. So that means the third one is the correct one. The next one. 2 electrons projected in a uniform magnetic field at right angle with 2 different velocities completes their circular path in the same time. Electrons are there moving in the same magnetic field with different velocities. They complete their circular path in the same time. Let's just see how it is related. Force, we know that it is your QVB. There it is 90 degrees, so it is your sine pi by 2. And it is equal to the centripetal force acting there. So it is equal to mv square by r. Now if I cancel v, in that case what I will get for v? V you will be getting QBR by M. Now let's see what is the time period, because we need that it is having or completing their path in same time or not. So let's take what is the time period. Time period will be your 2 pi r by v. Now you see here, if I take r by v from this one, what it will be? It will be your m by qb. So here it is your 2 pi m by qb. Now you see you have the 2 electrons. It means mass is same. They are moving at right angles, so 90 degrees for both. They are moving with different velocities. Now velocity term is not there in this expression. So obviously in this particular case, the time period will be same. So it is true. And let's take now, the time period of revolution does not depend upon the velocity of the charged particle. So this is also true, because we have seen that this expression is same. It is independent of the velocity of the charged particle. So this is also true. Now just read it out together. Two electrons projected into a uniform magnetic field at right angle with different velocities complete their circular path in same time, because the time period of revolution does not depend on velocity of the charged particle. This is the correct explanation of the assertion statement. So the first one is the correct option. Let's take the next question. Assertion is the magnetic field along the axis of a thick conductor carrying current is 0. Now here, if you consider that you have a conductor or a thick conductor is there and the current is flowing through it, then along its axis it will be 0. Obviously here in this particular case, if I take that it is carrying current, it will flow through the entire cross section, and in that case we know that magnetic field will be proportional to the radius there. That means radius means it is the distance from the axis there, as long as you are taking it inside. So obviously in this particular case, if it is said that it is along the axis, obviously it is 0. That means it is true. And the reason is that electric current flows only on the surface of the conductor. This is wrong, because the electric current through this conductor will be flowing through the entire cross section. So in that case, if you are taking DC, if it is AC, in that case it will have a skin effect also there, but of course it is there for very high frequency there. So that means it will be passing through the hollow cylindrical shell, you can assume. Then it will be flowing through the outer one, not through the inner one, and its thickness will go on decreasing as you are increasing the frequency there. But in general, if it is said, that means we will assume that it is we are talking about the direct current there. So in that case, it will be flowing through the entire cross section if it is a thick conductor there. So this is false. So assertion is true, reason is false. That means the third one is the correct option. Let's take the next one. The coil of a spring comes closer to each other when current is passed through it. Suppose you have a coil, suppose this is the coil and it is carrying current. Now, if it is carrying current, in that case, what will happen? Through two loops, if I consider, or two adjacent one, if I consider, the current will be flowing in the same direction. And if the current through two wires is in same direction, there will be a force of attraction. And if it is attraction, definitely they will come closer. So that means this is true. Let's take the reason. It is because the coils of a spring carry current in the same direction and hence they attract each other. So this is also true. In fact, it is the correct statement also. Let's just see it together. The coil of a spring comes closer to each other when the current is passed through it, because it is because the coils of a spring carry current in the same direction and hence attract each other. So it is explaining it correctly and completely. So the first one is the correct option. Let's take the next one. In the absence of an externally applied electric field, the displacement per unit volume of a polar dielectric material is always 0. In absence of external electric field, if you consider, all those dipoles which will be there in that dielectric material, if you consider, they will have their orientation in random direction. So the net displacement, if I consider per unit volume, will be 0. This means this is the correct statement. And let's take the reason now. In polar dielectrics, each molecule has a permanent dipole moment, but they are randomly oriented in the absence of externally applied electric field. So obviously this is also true, because they will be randomly oriented, so net dipole moment, if I consider, it will be 0. So let's read out again assertion and reason together. In absence of an externally applied electric field, the displacement per unit volume of a polar dielectric material is always 0, because in polar dielectrics, each molecule has a permanent dipole moment, but these are randomly oriented in the absence of an externally applied field. So this is explaining it completely. That means it is the first one is the correct option. Let's take the next one. The potential energy of a magnetic dipole is maximum when it is oriented antiparallel in the direction of the magnetic field. Now, potential energy of the dipole, if you consider magnetic dipole, it is your minus m dot b. That means it is your minus mb cos theta. And if it is said that it has maximum value, if theta we take it as pi, so it is your cos pi. So in that case, it will be your minus mb cos pi. Cos pi is minus 1, so it will be mb. That is the maximum value. So in that case, this one will be maximum when it is kept antiparallel. That means it is true. And now we will take the reason. It is because the work done is maximum when the magnet lying in the direction of the magnetic field is turned so as to make it antiparallel to the direction of the magnetic field. Obviously, in the direction of the magnetic field, if the magnetic dipole is kept, it is in stable equilibrium. So minimum energy will be there. And if you want to put it in antiparallel direction to the magnetic field, in that case, you will have to do some work. And work will be done, and that will be the maximum one, because one is giving you the most stable orientation, theta equals to 0, and most unstable will be your theta equals to pi. So obviously in this case, the work done will be maximum. That means this is also true. And if you read it together, assertion and reason, you'll find that it is explaining it completely and correctly. The potential energy of a magnetic dipole is maximum when it is oriented antiparallel to the direction of the magnetic field, because work done is maximum when the magnet lying in the direction of the field is turned so as to make it antiparallel to the direction of magnetic field. So that means this is also giving you the first one as the correct option. Let's take the last one. A beam of electron can pass undeflected through a region of electric and magnetic field. Remember, if you have a beam of electron, that means we assume that we have the electrons going in the region of electric and magnetic field. So it will experience force due to electric field given by E. E is the charge on the electron, if I assume. It will experience force due to magnetic field, that is your EB sine theta. So if it is there that the two are equal in magnitude and opposite in direction, then it can go undeviated, undeflected, because the net force on that will be 0. So that means this is true. And now let's take the reason. Force on a moving charge due to magnetic field may be 0 in some cases. Now this is true. Force on a charge in the magnetic field, if I consider this is your EVB sine theta, it may be 0 in many cases there. When suppose it is moving in the direction of magnetic field there, in that case it will be 0. So in some cases it is 0. This is true. But let's see that whether it is giving the correct explanation for this assertion statement or not. A beam of electron can pass undeflected through a region of electric and magnetic field, region of E and B, because force on moving charged particle due to magnetic field may be 0 in some cases. Now this is not explaining that how it can go undeflected in the region of electric and magnetic field. For magnetic field, it can explain that it may be 0. So it is not the correct explanation, although both statements are correct. So B is the correct option for this particular question. This was the discussion on assertion and reasoning questions on magnetic lines of forces and magnetism. In our next discussion, we'll take up the electromagnetic induction